Welcome everyone to this second program. Uh, this again consists of loops, and as it is with programs, we will try them first. If you cannot find a solution, that is when we will come to this particular area and look at the solution. Okay, so let's try this examples. So the first one says there are four parts to this example. Okay, the things that we'll be covering is mainly loops. Correct. We also have these operators. Okay, these mathematical operators that are provided. We also have a function over here, a power function over here to raise the power of this particular equation. Apart from that, we are mostly using loops, okay, and then maybe some things with print statements. So let's dive into it. We'll first calculate simple interest. Okay, so for calculating the simple interest, uh, just simply write SI equal to, and the um, problem, the equation is just P into T into R divided by 100. Okay, so that's P. Uh, I'll just write it P into T into R divided by 100. That's simple enough. Okay. But for this, we do need require the values of P, T, and R. Alright. So let's take the values of P, T, and R. Now we are not taking this from command line, so it's a regular input. So input function which displays a message, sorry, which displays a message inside it, which says enter. So uh, yeah, yeah, amount. Enter principal amount. Okay, and then whatever is the principal amount, we'll assign it to P. Of course, that will be a string, so we'll have to convert it to an integer. All right. Then, as we did for integer, we also have to take the number of years. Okay, so that's t. That's the time duration. Okay, so that is again, it could be a float. So float and then input. Usually, this is not a good practice. Okay, how you should do it is you should write input. Okay, inside it should you should write enter, enter time duration. Now once you have your time duration, what you'll do is you'll encapsulate this into another function which is float. Okay, and then you will basically assign this to t. Okay, same goes for the third one. So now r is equal to, right, r, sorry, input, enter, rate of interest. Then we have to encapsulate this in Rate of interest can be a floating value, so FL over into and then R. Okay. So now once you have all these, the only thing remaining is to simply calculate all these and print it out. So the sorry, it should be a print statement. So print the simple interest is, and then we have uh, what we have is the value, right? So simple interest is and comma and SI. Okay, so this is what we will have. Though this is what we will have. Okay, and after that we have to have the compound interest. So let's have the calculation for compound interest. We'll consider the same inputs, right? So let's move this particular comment from here to say yeah, right? And these are the inputs. Okay, so let's have the formula for compound interest first. Okay, formula for compound interest. It goes something like this. I'll copy the entire formula and then we'll make the changes. Okay, so CI for compound interest equal to, and this is the formula. Okay, now P we can subtract uh, this raised to power T. Right. So let's first codify the entire thing. All right. So what do we have first? What I'll suggest is the way in which I am coding it. Okay, and that is working from the inside out. All right. That is R by 100 first. Okay, so that's R divided by 100 divided by 100. That's simple enough. Put it in a bracket. Okay, add 1 to it. All right, so 1 plus. Again, enclose it within brackets so you don't have any problems. Okay, then you have to raise this to the power t. Okay, so either what you can do is over here you can use a function called POW. Okay, so POW is the power function which will take two parameters. First is the thing that you have to raise, and second is the power to which you have to raise. Okay, so that's T. Sorry, it's not smaller t, it's capital T. Okay, after having done that, we need to multiply the entire thing with P. So this is again multiplied by P. Alright, and now we subtract this entire thing with, okay. Now keep in mind that I am calculating only the interest. There is only the compound interest. It's not the entire sum. It is the interest that is accrued on that particular amount. Okay, so that is why we have to subtract the principal amount from the whatever is accumulated at the end. Okay, so Ci equal to, and that will be the entire thing. Okay, so now that we have these three things, let's just check if this one works. Save it and run it. Okay, so Python 3 p2 dot py. Last for a principal, I will give it a simple principal, a simple duration, maybe a 4.5 years, and an interest of 10. Okay, okay. So simple interest, it did calculate compound interest. It did calculate, but it did not print. Okay. Also, we see some errors, some minor mistakes. That is, we did not add spaces. So let's do that very quickly. Okay, colon this, and then print. So, okay, and then we require CI. That should be the entire solution. Let's clear the screen and run this one more time. 100, 4.5 years, interest of 10. We have a simple interest of 45 and the compound interest of 53, and so much. That's it. So that is about the operators. Alright, so how to use these operators. Okay, you have your multiplication operators, and of course, when you have the problem of uh, multiple operators, okay, which have multiple uh, of varying priorities. Alright, so what do we do? We To ensure that there is no conflict in the priority, we add brackets. Correct, because otherwise it will override some of the other operators. Okay, so some operators have precedence over others. What do you mean by that? Is if you encounter, say, uh, a multiplication or a division operator. Okay, these have priorities over addition and subtraction. Okay, subtraction. Okay, so whenever there is a case where these two are used simultaneously, what will happen is this will be executed first, and then these will be executed. Okay. Uh, Also, if you have raised to the power, so as we did over here, we used a power function, right? We can also use raised to the power function, right? Uh, so raised to power functions, that is this we have this. okay, which was shown over here in our problem statement. It was shown over here, okay. So raised to power function, that is 2 asterisks, has more precedence over multiplication and division, and they have more precedence over addition and subtraction. Okay, so of course, and then everything has lower precedence than the opening and closing brackets. Okay, so if we encounter opening and closing brackets anywhere, irrespective of what the operator is, that will be given a priority. That is why we have included this brackets everywhere. Okay, so while forming this particular formula, you saw how meticulously, how uh, carefully I went through the process. Right, I first wrote R by 100, then a plus. Right, why? Because plus and division operator are side by side over here, so I don't want them to get mixed up. So what do I do? I first write R by 100. I include that in the bracket. Then I add a plus operator, 1. Then I add the whole thing in a bracket. Then the power function, I added the entire whole thing in a bracket. I multiplied by P and then a minus sign. Okay. So this is regarding the precedence of operators, the operators and the precedence. Okay. Uh, Stop this, and the second portion, that is the Fibonacci series and printing pattern, will continue in the next video.